Welcome to the second seminar of PDM analysis for this Rankin 2020 conference. This seminar is about analysis of screw compressors and expanders using lower order models. So we will talk today about SCORG and GT-SUITE for modeling these machines using lower order models, and we will talk about new thing that PDM analysis has just realized, which is the online platform for calculation of these machines. Today's presenters are myself, Ahmed Kovacevic. I'm director of PDM analysis, and I'm director of the Center for Compressor Technology at City University of London, and Mr. Alex Krupa, who is engineer in PDM analysis, very instrumental in using these lower order models, and he is research assistant at City University of London. So SCORG is pioneered in the 1990s at City University back on the research which we have been doing for a number of years on these machines, and has been realized in a universal platform for ubiquitous design and analysis of screw machines, which is now commercialized by PDM Analysis Limited, which is a spin-off company from City University of London. It is the platform that consists of several modules, which you can see on the left-hand side, and connects to several external and internal software, which you can see on the right-hand side of this slide. So today we are going to talk about setting up of the machine and using the lower order models, which you can see rounded in this red circle in here. And this is used for calculation of gas pressures, temperatures, leakages, and efficiencies, powers and flow rates, as well as forces and boundary maps of these machines. The whole process starts by importing the profile in a SCORG interface, which you can see on this screen, and setting up the characteristics of the machine, selecting of the machine as you can see in here, or setting up other characteristics of this machine in terms of its working chambers and in terms of parameters that this machine operates on. When this is all set up for lower order modeling using thermodynamic chamber models, SCORG produces important data like a volume curve, suction and discharge, or low pressure and high pressure port areas, as well as leakage areas, which are then used in thermodynamic models to calculate performance in all of the machine. And depending on what setup is used, whether is it internal thermodynamic solver of a SCORG, or is it external GT-SUITE solver, results could be produced. So if it is internal model, then obviously pressure and temperatures, as well as radial forces and boundary maps could be produced using this internal SCORG thermodynamic model. But equally, external GT-SUITE model could be used. GT-SUITE is the software from Gamma Technologies, which is basically a system solver, softwares for solving systems. And in this case, it uses inputs from a SCORG in terms of this volume, area, and other curves, as well as the basic parameters to set up the multi-chamber model, which includes all the leakages and all areas of the suction and discharge port, and it can directly calculate performance of screw compressors or expanders being run from SCORG directly or from GT-SUITE. And I will hand it now to Alex to talk a little bit about examples of calculation of these machines using SCORG and GT-SUITE.
Thank you. So first study was performed on oil-free screw compressor with 3-5 configuration of rotor lobes and N rotor profile using both SCORG thermodynamics and GT-SUITE. The compressor was measured in the laboratory of City University of London. The results obtained by SCORG thermodynamic model as well as GT-SUITE were compared with experimental data. It can be observed that the alignment of both models with experiment is very good. Additionally, GT model, which uses 1D flow calculation for ports, provides an idea of the oscillations at the discharge of the compressor. Bearing forces are calculated based on the performance of the predictions from either SCORG or GT-SUITE and are used for selection of bearings. This example of oil-injected compressor shows the process of optimization of the compressor configuration for a selected duty to maximize compressor performance. Study was performed based on the existing compressor with 4-6 configuration of rotor lobes, retrofitting it with rotor of N profile, which have the same diameter and center distance as the original rotor, rotors with reduced center distance, and lastly with 4-5 lobe configuration using N rotor profile. SCORG allows for automation of optimization process with pressure, speed, and temperature loops. 5 cases were run for each profile setup with different discharge pressures, and it can be observed that 4-6 N profile with reduced center distance is optimal solution in this case with minimal specific power and maximum flow rate. Another case study was done on twin screw expander. SCORG alongside GT-SUITE are capable of calculating the performance of expanders and their systems like organic Rankine cycle with refrigerant or air as a working fluid. The results obtained using SCORG and GT-SUITE 1D chamber model were compared with CFD analysis prepared with SCORG and ANSYS CFX solver, and the experimental data recorded at Dortmund University. Both simulations result align very well with the measured data, demonstrating the versatility of SCORG for performance prediction and optimization of screw machines. And back to Professor Kovacevic.
Thank you very much, Alex, for your interesting presentation. And I would like to spend a minute on talking about our latest release, which is basically SCORG Alto. It is called SCORG Alto. SCORG Alto is the online web platform for calculation of screw machines, and it allows ubiquitous modeling of positive displacement machines using SCORG on virtual machines on a Microsoft Azure platform. The system allows very easy ordering of the virtual machine. It doesn't require any additional or complicated procedure from IT departments of the companies, and allows for a short-term licensing of a SCORG, as well as sharing licenses with your colleagues if you required that. It is a flexible platform that allows changing of a capacity of the machines, and we look forward to our customers trying and using this. So if you are interested, please do not hesitate to contact us, and our contact details are here. Thank you very much for listening to our presentation.